It's Niora, and this is my lab video report for Physics 2212 on Lab 1 charge tapes. This video contents are introduction, related concepts, experiment, computer model, and conclusion. Introduction. The purpose of this lab was to make pieces of charge tapes, observe the interactions between them, use them to calculate the amount of the charge on the tape, and represent them using a computer model plus some calculations. And the result, the magnitude of the charge on tape was calculated to be 5.3694 to the minus 8th power coulomb. And here is a preview of the experiment. The left image that you can see is the actual experiment that we did, and the right image is a computer recreation of that experiment. The related concepts to this experiment are Newton's second law, which states that momentum is proportional to the force that is applied on the system, Coulomb's law, which is explaining the amount of electric force something gets from the charges and the distance squared, force of gravity, which in this experiment was simplified to simply m times g, the gravitational constant, and finally the electric field that something with charge applies to every space around it, and is calculated to be k times the charge divided by distance squared. It's the magnitude. Initial conditions of this experiment: the tape that was used in this experiment was measured to be 0.2 grams of mass, 20 centimeters in length, and 1.5 centimeters in width. The experiment, as you can see from the image on below, it was the experiment rubric that was given to us, and it was carried out the same as you can see. The system is the tape B, one on the top, and the surroundings are tape A and the whole Earth for the gravity. And the distance between two tapes at the point of experiment was measured to be 11.5 centimeters. Here is the computer model that you can see. This was made using the coding program GlowScript online. And the results, as you can see, the tapes repelled each other, which means that they had a same charge. And as you can see from the right image in the computer model, the force of gravity that was pulling the tape down and the force of electric force that was pushing the tape B up applied from the tape A was equal in magnitude. Therefore, the tape stayed in place. And the charge on tape was calculated to be 5.3694 to the minus 8th power, 10 times minus 8th power coulombs. Discussion. Assumptions that were made for this experiment was air resistance, friction, and many other factors are negligible. Long tapes are represented as a point charge, and the charge is evenly distributed through the tape. The possible sources of error that could have happened in this experiment are the previous assumptions not being true. For example, in real life, air resistance has effects, therefore it could have altered the outcomes. Human errors such as measurement or camera angle errors. And finally, the tape's charge could have been discharged by contact with human hands. What if protons had negative and electrons had positive, so inverse charges? The results of the experiment would not change, as the tapes would still have the same charge and they would have repelled each other same, but they would have other charges. And why is it important to handle tapes as little as possible? Since tapes are charged, they neutralize when they touch hands as electrons flood back into them. Conclusion: successfully calculated the magnitude of the charge in tape using electromagnetic principles, and successfully recreated the experiment using a computer model. Thank you.